how many 3-digit numbers are there for which the product of their digits is more than 2 but less than 7? So the product has to be either 3 or 4 or 5 or 6. This is a permutation and combination question. The digits available to fill each of the 3 dashes. The dashes represent the digits of the 3-digit number. The digits available are 0 to 9. When we're using the decimal system, but since the product is non-zero, you cannot use a 0. So 1 to 9 are available to us. Each dash should contain a 1 to any of the digits from 1 to 9. The product of those 3 digits should be either 3 or 4 or 5 or 6. Now remember that multiplication is commutative, so 1 into 2 is equal to 2 into 1, for example, which means that once you have a correct selection, a valid selection, you can put it in any order. So the example that I would give you is, if I select 1, 1 and 3, I can put them in any order and they would all be valid 3-digit numbers. For all these cases, the product is 1 into 1 into 3, or 1 into 3 into 1, or 3 into 1 into 1. They're all going to be 3. So the thing to do here is to find valid selections, and then all permutations of those valid selections are valid. The products possible are 3 or 4 or 5 or 6. So what can we do? We can, like I showed in the example here, you can take 2 1s and a number other than 1. So 113 is a selection. Similarly, 114, 115, 116. Those are the selections where you have 2 1s. Then you can do 122. You can also do 123, and that's all you can do. Even something like 222, the product would exceed 7. Now it's a question of how many permutations are possible for each of these. 113, 3 items where 2 are similar, 3 factorial by 2 factorial, there are 3 permutations. I've shown them here. Same here, 3, 3, 3. Here also you have 3 items of which 2 are identical, so it's again 3. Here you have 3 distinct items, so 3 factorial, 6. Your final answer is 3 plus 3 plus 3 plus 3 plus 3 plus 6, 21. If f of 5 plus x is equal to f of 5 minus x for every real x, and f of x equal to 0 has 4 distinct real roots, then the sum of the roots is how much? Now, it's given that f of 5 plus x is equal to f of 5 minus x. I'm saying let one of the roots be 5 plus alpha. That's my assumption. That means f of 5 plus alpha is 0, but by the given rule, f of 5 minus alpha will also be 0, which means this would automatically lead to a second root being 5 minus alpha. Similarly, if I let a third root be 5 plus beta, then the fourth root will be 5 minus beta. Irrespective of the values of alpha and beta, if you sum these 4 things up, that's the sum of the roots that they want. The plus alpha and the minus alpha will cancel, plus beta minus beta will cancel. The sum of roots is basically 5 plus 5 plus 5 plus 5, 20. Now it's interesting to also look at this graphically. F of 5 plus x is equal to f of 5 minus x is basically a graph which is symmetric about the line x equal to 5. So some function that might look like this. So you can see that the average of these two is 5. Let me use another color. The average of these two roots is 5. The average of these two roots is also going to be 5. The average of the 4 roots is going to be 5. So the sum is going to be 20. Viru invested 10,000 at 5% simple interest, and exactly after 2 years Joy invested 8,000 at 10% simple interest. How many years after Viru's investment will their balances, that is principal plus accumulated interest, be equal? So basically amounts should be equal. When does that happen? So we have a very simple question on simple interest. Now the simplest explanation that I can give you is to just give you the formula for amount. We know amount is P into 1 plus RT. Equate the two amounts. So 10,000 into 1 plus 5%, 0.05 into T years. That's the amount T years after Viru's investment. It has to be equated to the amount for Joy, which is 8,000 into 1 plus, he has 10%, but his investment took place 2 years after. So he's invested for a duration of time which is 2 years less than Viru's duration. So that's going to be T minus 2. So the second guy investing for T minus 2 years and the first guy investing for T years leads to the same final time. So these are amounts on the same year. If you equate them and solve for T, you will get the answer. The answer would be T is equal to 12. Now if you don't want the hassle of writing down this equation, expanding and everything, you can think of it like this. This is something that increases by 500 a year. This, because it's 5% of 10,000. This is something that increases by 10% of 800, that's 800 a year. But they're not starting at the same time. So he's starting at 10k. Year 1, year 2, by that time he is already at 11k. And then he is increasing at 500 every year. At this point in time, Joy has just invested and he is at 8k. And then it is increasing at plus 800 per year. So if you look at the delta here, it's plus 300. The gap between them is closing at 300 rupees a year, but the initial gap is 3000. So you can simply do 3000 by 300 and say it's gonna take 10 years after Joy invests, which is the same as 12 years after Viru invests. This 12 is what you're looking for. You don't need this equation with 3 brackets and this expansion and the all the transposition and stuff to solve it. It can be done logically with a little bit of a delta approach. A train traveled at 1/3 of its usual speed and hence reached the destination 30 minutes after the scheduled time. On its return journey, the train initially traveled at its usual speed for 5 minutes, but then stopped for 4 minutes for an emergency. The percentage by which the train must now increase its usual speed so as to reach the destination at the scheduled time is nearest to which of these 4 numbers? So this question only needs direct and inverse proportion. It's just about the proportionality between distance, speed and time. So we have speed is inversely proportional to time when distance is constant primarily. So let's look at it bit by bit. 1/3 of its usual speed. So you have speed and time. 1/3 of its usual speed means the speeds are in the ratio 3:1, which means that the time should be in the ratio 1:3. And this 3t was 30 minutes more, 30 minutes late. So it's t plus 30, which gives you t is equal to 15 and t plus 30 is 45. So at its usual speed, it goes from A to B in 15 minutes and return journey also in 15 minutes. On its return journey, the train initially traveled at its usual speed for 5 minutes. So you have a certain distance. It did 5, notice, is 1/3 of the 15 that we just found. So 1/3 of the distance was done in 5 minutes, and if you had continued at this rate, you would have done the remaining 2/3 in the next 10 minutes. This is what should have happened. But it stopped for 4 minutes for an emergency, so it lost 4 minutes there, and if it should reach at the scheduled time, it should now cover this distance at 6 instead of 10. That is the next part of this, speed and time. Instead of 10, if you're going at 6, then the speeds are going to be in the ratio 6:10 or 3:5. So the required speed now is 5/3 times of the usual speed, and the required answer is just 5/3 minus 1, 2/3, 67%. If log 5 to the base 4 is equal to log y to the base 4 into log root 5 to the base 6, then y is how much? Pretty basic logarithm question. Primarily need the identity with the base change. Log, let's call it x to the base b divided by log y to the base b can be written as log x to the base y. That's the identity we need here. So on the LHS we have log 5 by log 4 to some base. It just has to be the same base. On the RHS you have log y to the base log 4 into log root 5 to the base log 6. If you put a 2 here and a 2 here, you know what happens to the coefficient of a log? It can be using another identity. You can put it as the power here. So then the RHS becomes log y by log 4 into log 5 by log 36. Log 5, log 4. Log 5, log 5, log 4, log 4. We basically have log y by log 36 is equal to 1, which means y is 36. The number of real valued solutions of the equation 2 raised to x plus 2 raised to minus x is 2 minus x minus 2 whole square is how many? Now this question is best solved using a graphical approach, because we don't need to find the values. What are the values of x is not the question. How many values of x are there? Especially when the values are not required and you only have to find the number of solutions, graphical approaches might be very useful. So let's see what this looks like. 2 raised to x looks like this. It's an exponential function. It will grow like this. 2 raised to minus x is basically the reciprocal of that. Also, you know that if x is replaced with minus x, it's going to be the mirror image on the y-axis. So it's going to fall the way the other one rose. If you want to sum these two things, what does that look like? That looks something like this. This point was 0, 1. So when the two ones add, your output is going to be 2 when x is 0. So that's the graph on the LHS. What about the RHS? There's a lot happening here. First you have the x square curve, which is a parabola, but then it's shifted 2 units to the right. So it's gonna go through 2, 0 parabola, but then it is negated. So it's gonna look like this, and then it is upshifted by 2 units. So finally it will look like this. This point is gonna be 0 minus 2, because if you substitute x equal to 0, you'll get 2 minus 4 minus 2, and if you substitute x equal to 2, you'll get 2 minus 0 2. So you have these points. This was 0 2. Now you'll basically see that the lowest point on the LHS is lowest y value on the LHS 2. It happens at x equal to 0, and the highest y value on the RHS is 2. It happens only at x equal to 2. So these two will never meet. It is not drawn accurately. It should be at the same level. Anyway, these two graphs will never meet. The number of real valued solutions will be 0. A straight road connects points A and B. Car 1 travels from A to B and car 2 travels from B to A, both leaving at the same time. After meeting, car 1 takes 45 minutes, car 2 takes 20 minutes to complete their journeys. If car 1 travels at the speed of 60, what is the speed of car 2? Now, this is a scenario which has a direct formula for solving it. This formula can be derived. It was derived, but it's not worth deriving over and over again. It is very useful to remember this for this particular scenario where two people are starting simultaneously and going towards each other's starting points, and the time they take after meeting is given. There are a couple of formulae here. One of them is S1 by S2 is root of T2 by T1, where T2 and T1 are the times taken by person 2 and person 1 after the meeting. Now, the other formula here is time taken to meet. After they start, how much time does it take before they meet? That is root of T1 into T2. Remember that this is an inverse root relation. This is what you need here. T1 is 45, T2 is 20. You take out the 5s, you get 4 by 9. You take the root, you get 2 by 3. S1 is given as 60, so S2 should be 90. Let A, B, C be positive integers such that the sum of A and the mean of B and C is 5. In addition, the sum of B and the mean of A and C is 7. Then the sum of A and B is how much? Now, this is a question. Notice that you have an equation here and an equation here, and you have 3 variables. 2 equations, 3 variables is not completely resolvable, but at the same time, so not resolvable means you cannot find unique values for A, B and C. But at the same time, there are some situations where even if the whole thing is not resolvable, the expression they ask for can be found. That is not what is happening here. What is happening here is that you have 2 equations, 3 variables, but the integer constraint is helping us find unique values for A, B and C, after which we can find A plus B. So what do I mean by integer constraint? Here's quite a simple example. X plus y is equal to 2. X, y belongs to natural numbers. This is one equation, 2 variable, but we know that it has to be 1, 1. So there are constraints that will reduce your solution space sometimes to the point that you'll get a unique solution even if the number of variables is less, number of equations is less than the number of variables, and that's what has happened here. So just the background on what's happening here, and now for the solution. We have given A plus b plus c by 2 is 5. What you want to do is double this immediately. 2a plus b plus c is 10. And if you do the same thing to the second equation, you will get b and the mean of a and c. Doubled, it will look like this. A plus 2b plus c is 14. And if you subtract these two, you will end up with b minus a is 4. B is a plus 4. You want to take this and throw this into either equation. You will get 2a plus a plus 4 plus c. 3a plus c plus 4 is 10. 3a plus c is 6. Now you'll notice that this is still one equation, two variables, normally not resolvable, but with the positive integer constraint, there's only one solution. A has to be 1, C has to be 3, and when you throw that 1, you will get B is equal to 5. So finally, A plus B is 1 plus 5, 6. If x is equal to 4096 raised to 7 plus 4 root 3, then which of the following equals 64? Admittedly, one of the tougher questions in this quant section, because there are some inductive elements here. You have to notice that 4096 is the square of 64. You have to notice that the conjugate to 7 plus 4 root 3, which is 7 minus 4 root 3, is also its reciprocal. 7 plus 4 root 3 into 7 minus 4 root 3 using the a plus b into a minus b form. The other side should be a square minus b square. 7 square is 49. 4 square into 3 is 48. So you notice that the product is 1. You have to notice these things. But provided you know the relevant theory and concepts required, even if you didn't spot these things just by looking at the numbers present in the question, the options kind of force you to notice these patterns. Anyway, what you need to do here is start with x is equal to 4096, which is 64 square, raised to 7 plus 4 root 3. I want to get rid of this. After that, so if I can get rid of that power, I'll have 4096. After that, I can take square root and get 64, which is my target value on the RHS. So what I do here is I would raise both sides by 7 minus 4 root 3. Now you know that a raised to m the whole raised to n is a raised to mn. So the RHS is going to become 4096 raised to 1. That is the step. So you have x raised to 7 minus 4 root 3 is 4096. Now I am raising both sides by half, which is basically square root. At which point I have x raised to 7 by 2 minus 4 root 3 by 2 is 2 root 3, and on the RHS I have 64, which is what I want. Now a raised to m minus n can be written as a raised to m by a raised to n, and that's it. That is one of the options. We have brought it into the form of one of the options. That is your answer. The mean of all 4-digit even natural numbers of the form AABB, where a greater than 0 is. So there's average, you could argue weighted average, you could argue number systems, combinatorics, whatever. Primarily number system and weighted average. So what is happening is these two dashes can be filled by either 1 1 or 2 2 or 3 3 all the way down till 9 9, while these two dashes can be filled with either 0 0 or 2 2 or 4 4 or 6 6 or 8 8. Now quite simply I would say the answer is just take the average of this 5, just take the average of this 5, the average here would be 4, the average here would be 4. That would be the answer. But I suppose that would not be convincing enough for everyone. So let's look at this in a little more detail. So what's happening here is you want to look at it from the point of view of the place values of the digits in each position. So if you take this position, every time a 1 sits in the dash, the place value is 1000. Every time a 2 sits in it, 2000, 3, 3000, all the way down till 9000. Now you will notice that the number of times that dash is filled by 1 is the same as the number of times the dash is filled by 2, all the way down till 9. So these place values have a weight ratio of 1:1:1:1, which basically means the weighted average is just the average. That is how you will get the average of the place values of every number that gets placed in this dash by the time we list all 4-digit even natural numbers. By the time we list all of them, the place value of all the digits thrown into this dash is 5000. So that's the logic here. Every number is represented in the dash at an equal frequency, every number from 1 to 9. So the average of those numbers is 5, the corresponding place value is 5000. And then you can use the same logic to say that you'll have 500 as the average place value for every digit thrown into the hundreds place. For the tens place, it's the average between 0 to 468, which is again equal frequency, so the weighted average simply reduces to the simple average. 4, the place value is 40, and again 4, the place value is 4. So that is how you get the mean as 5544. One more point regarding this, one confusion that somebody who's solving this could be, can I have the number 2222? Because then A is equal to B. This is actually not a problem because the question doesn't specifically say A not equal to B. So this also can happen. So you don't need to worry about that issue. It's just the average for each space, 5544. The number of distinct real roots of the equation x plus 1 by x the whole square minus 3 times x plus 1 by x plus 2 is equal to 0. It's a simple substitution that converts this into a quadratic. They haven't tried to disguise this at all by giving us a bracket and a square and a bracket without a square. So they've made it easy to identify that there's a substitution. So if you substitute x plus 1 by x is equal to y, you'll end up with y square minus 3y plus 2 is equal to 0. This is basically y minus 1 into y minus 2 equal to 0, which means y is equal to 1 or 2. But what is y? Y is x plus 1 by x. X plus 1 by x is an expression whose magnitude should be greater than or equal to 2. It's either greater than or equal to 2 or it's less than or equal to minus 2. So 1 is not possible. 2 is possible. X plus 1 by x equal to 2 will solve to give you x is equal to 1. This is the only value that's possible. So the number is 1. A person spent 50 on desktop plus laptop, desktop at 20% profit, laptop at 10% loss, overall 2% profit. What is the price of the desktop? The most efficient way of doing this is to use weighted average, especially with a number line involved. So you have profits weighted by their corresponding cost prices will give you overall profit. So I will take my 20 and my 10% loss, I'll write it as a minus 10, and then the overall is 2%. That's a distance ratio of 18:12, simplifies to 2:3. Flip it and you get cost prices in the ratio 3:2. Desktop was a 20% profit. So out of the total 5 parts, 2 parts was desktop. 20,000 rupees for the desktop, 30,000 rupees for the laptop. Required answer is 20,000. Among 100 students, X1 have birthdays in Jan, X2 in Feb, and so on. X0 is the maximum of these 12 values, then the smallest possible value for X0 is how much? Options 8, 10, 12, 9. I found it interesting that this was thrown into the mix. This is based on something known as Pigeonhole Principle, which I have encountered more from a logical reasoning perspective than from a quant perspective. So the idea is, so it's named after, I think, birdhouses and pigeons. If you have, let's say, 17 pigeons and they're sitting in 16 birdhouses. So these things have these small holes in front. You know that there's at least one hole that contains 2 pigeons. Because if every hole contains 1 pigeon, you can only accommodate 16 pigeons. You cannot accommodate 17. So to abstract it a bit more, if you have to throw n plus 1 items into n boxes, at least one box will contain 2 items. So that's the thing. If you want to throw n plus 1 items into n boxes, at least one of the boxes will have 2 items. And you can extend this to, let's say if I have 5n plus 1 items and n boxes, at least one will contain 5 plus 1, 6 items. That's basically what they're shooting for in this question. Anyways, you can look at it this way. If each month is given 8 people, that will only account for 96 people. We have 100 people. So at least you have to remove 4 of these 8s and throw 9s there. That is the way to minimize the maximum. I'm going to remove this 96 from here. The max value is now 9. With 9 it is possible. With 8 it is not possible. Now obviously you could have done 8, 8, 8, 12 or something, but that's not what they're asking us to optimize. They're asking us to minimize the value of x0, where x0 is the maximum of the 12 inputs. So this is not optimal. This is the optimal solution. At least 4 of those 12 variables should be 9 and the others are 8. This is the optimal solution that will give us the lowest value of x0, which is 9. One last point, if you want to do maximum abstraction here and reduce everything to a single formula, the answer is 100 by 12. Take its ceiling. Ceiling of the number of students divided by the number of months, 9. Two persons are walking beside a railway track at respective speeds of 2 and 4 per hour in the same direction. A train came from behind them and crossed them in 90 and 100 seconds respectively. The time in seconds taken by the train to cross an electric post is nearest to which of these numbers? Now this is based on trains crossing from the time and distance chapter. The relevant formula is time is relative distance by relative speed, and this relative distance is basically the length of the two objects where one is crossing the other or they are crossing each other, and the relative speed is s1 plus or minus s2, minus if they are going in the same direction, plus for opposite direction. Now it reduces based on some of these values turning 0. For example, the train has a length, the men don't, so L2 is 0, but they both have speeds. Later on we deal with a train crossing a post. Train has length, post doesn't, at least horizontally it doesn't, and train has a speed, the post is just standing there. So the formula simplifies based on special cases, but this is the general formula when you have two objects with a length and both of them are moving. Anyways, you will deal with time taken to cross a man is length of the train by speed of the train minus speed of the man. Time taken to cross a post is length of train by speed of train. That's it. There's nothing else in the denominator. Now to solve this efficiently, you have to notice that the distance is same in all the cases, whether it is man 1 or man 2 or electric post, the distance is always the same. So we end up with speed is inversely proportional to time. So look at the speeds and the times that are given. Case 1, the time is 90 seconds and the speed is speed of train minus 2. And then you have speed of train minus 4, a smaller value for speed and a higher value for time. And then finally, when it is trying to cross the post, the relative speed is simply st, and we have to find the time for this. This is what we have. Now using these two data points, we can find st, and after we have that, we can find this number simply by using inverse proportionality. So you have two numbers in the ratio 9:10. So these two numbers are in the ratio 10:9. Now instead of cross multiplying, one handy trick that I like to use is, these are two numbers that differ by 2. It's 2 less than st, it's 4 less than st. So they differ by 2. And so the easy way of doing this is to rewrite 10/9 in a way that the numerator and denominator differ by 2. Once you do that, you can say that 20 is st minus 2 and 18 is st minus 4. If you look at it, it would make a lot of sense. Now that means st minus 2 is 20, st minus 4 is 18, and st is 22. Notice the inverse proportionality here. 20 into 90 is 1800, 18 into 100 is also 1800. So the time here is simply 20, let's say 18 into 100 by 22. 18 into 100 should be equal to 22 into answer. So the answer is 18 by 22 into 100. You know that 18 by 22 is 9 by 11, and you might remember that 9 by 11 is 81.8%. So then into 100 would be 81.8 from the options 82. How many distinct positive integer solutions exist to the equation x square minus 7x plus 11 raised to x square minus 13x plus 42 is equal to 1? What are the concepts at play here? We need the basics of exponents and the basics of quadratic equations. Now as far as a raised to b is equal to 1 is concerned, we either need a not equal to 0, b equal to 0. Any non-zero number raised to 0 is going to be 1. 0 raised to 0 is a very complicated business. Let's not get into it. Anyway, you can just, it's not going to be equal to 1. 2 is when a is 1 and b can be anything. And 3 is when a is minus 1 and b is even. Minus 1 raised to any even integer is gonna be plus 1. So you have to look for these cases separately. Case 1, b equal to 0 is basically x square minus 13x plus 42 is equal to 0, which simplifies to x square minus 6x minus 7x plus 42. It's basically x minus 6 into x minus 7 equal to 0. X is 6 or 7. Now the only thing to check is a equal to 0. 36 minus 42 plus 11 is 5, and 49 minus 49 plus 11 is 11. In both of these you get a non-zero number raised to 0, so they're both valid. We have found two solutions. Case 2, a equal to 1. That's when x square minus 7x plus 11 is equal to 1, which gives you x square minus 7x plus 10 equal to 0. This is x minus 2 into x minus 5. X equal to 2 or 5. So nothing to check here. Both of these will work. Case 3, a equal to minus 1 and b should be even. So then x square minus 7x plus 11 is minus 1, gives you x square minus 7x plus 12 equal to 0, which gives you x minus 3 into x minus 4, which is x is 3 or 4. Now before we underline them, let's just look at what happens to the power. 3 square minus 13 into 3 plus 42. Just look at whether the terms are odd or even. 3 square is odd, 13 into 3 is odd, 2 odds make an even, then you have another even. So b is even. So that works. Now look at the other case. 4. X square is going to be even, 13x is going to be even, 42 is even. The value of b is going to be even. 4 also works. So you got a total of 6 distinct values. 2, 3, 4, 5, 6, 7. 6 distinct positive integer values. From the 3 cases, the answer is 6. The area of the region satisfying the inequalities mod x minus y less than or equal to 1, y greater than or equal to 0, y less than or equal to 1 is how much? So a graph based question here. First thing you do is you throw the y to the other side, 1 to the other side. Y is greater than or equal to mod x minus 1, which is a much more comfortable form for us to deal with. Rest are fine. Let's draw the axis. You have your y axis, your x axis. Y greater than or equal to mod x minus 1. First draw y equal to mod x minus 1 and then figure out which side of it is what we want. Y is equal to mod x will look like this, and then you have to shift it down by 1 unit, giving us something that passes through. The lowest point is 0, minus 1. It passes through 1, 0 as it rises up on the right side of the y axis. On the left side, it is falling down to that point. Familiar V shape, shifted down by 1 unit. A few points for reference. That's the first one. Then you have y greater than or equal to 0. So again, what you want here is y greater than or equal to mod x minus 1, which is anything above these lines. So this is the region we're looking for, satisfying the first condition. The second one is y greater than or equal to 0. So draw y equal to 0. Everything above that is what we need. And the third one is y less than or equal to 1, which will be, let's put 1, everything below this line. So y is equal to 1, y is equal to 0, and y is equal to mod x minus 1. So bounded by these three regions, we have this area in between, which is a trapezium. So the required area is half into a plus b into h. You will see that this point is 2, 1, this point is minus 2, 1. So the parallel sides are 4 and 2, and the height, the distance between the parallel sides is 1 unit. So you can substitute half, 2 plus 4 into 1, you will end up with 6 by 2. 3 as your answer. A solid right circular cone of height 27 meters is cut into two pieces along a plane parallel to its base at a height of 18 from the base. If the difference in the volume of the two pieces is 225 cubic centimeter, the volume in cc of the original cone is how much? Now, this question is meant to be solved using similarity and proportionality. You don't even need to know that volume is 1 by 3 pi r square h. All you need to know is that v2 by v1 is equal to L2 by L1 the whole cube. So if you get two similar figures, if the ratio of some corresponding lengths is L2 by L1, then the ratio of the volumes will be the cube of that ratio of the lengths. That is all you need. You don't even need this to solve this question. So I wouldn't tag this as a mensuration question as much as I would tag it as a similarity question. Anyway, we have a cone. We'll look at the side view of it, which is a height of 27 and it is cut using a line plane parallel to its base at 18, which means if this is 27, then this is 18, which means this is 9. Now if you cut a cone parallel to its base, you'll be left with a small cone which is similar in shape. So the same shape but not the same size. Similar figures. The new cone and the original cone are going to be similar. So the side ratio here, as you can obviously see, is 9 by 27, which is 1 by 3, which means that the volume ratio is 1 by 3 cube is equal to 1 by 27. So then you have the small cone is to, okay, let's call it the volume of the small cone to the volume of the big cone, large cone, is 1:27. Let's take them as 1k and 27k. What is given in the second part is if the difference in the volume is 225. So okay, two pieces. So if you have the volume of the small cone as 1k and the volume of the large cone as 27k, then the volume of the frustum is 26k. The frustum is the part left over. Subtract the 1k from the 26k, so from the 27k, and you'll be left with 26k. What is given is that the difference in the volume of the two pieces, which should be the small cone and the frustum. The difference between these two, 26k minus 1k, is given as 225. That's 25k is 225, which gives you k is equal to 9. Then what is the volume of the original cube? So the answer is 27k, where we just found k to be 9. So it's 27 into 9, 243. A circle is inscribed in a rhombus with diagonals 12 and 16. The ratio of the area of the circle to the area of the rhombus is what? One of the tougher questions in this paper, because there are a lot of concepts coming together. If you miss any one of them, or if you cannot put them all together during the exam, you won't be able to solve this. So here's a geometry question, primarily Euclidean geometry concepts, and towards the end a little bit of mensuration as well. So what are the concepts that you need? One of them is if you have a right angle triangle and you drop a perpendicular, drop an altitude from the 90 degree, that altitude will split the right triangle into two smaller right triangles which are both similar to the original. Important concept. This is the concept behind the proof of Pythagoras theorem that we learned back in high school. This was used to prove Pythagoras theorem. Another concept that you would need is that diagonals bisect each other for all parallelograms, but they're also perpendicular in rhombuses. Diagonals perpendicular, and then you have some basic mensuration. Pi r square is the area of a circle, and half d1 d2 is the area of a rhombus. Now if you ask me, this seems like the biggest stumbling block as far as solving this is concerned. This is the one that people are most likely to miss out on. So this is the crux of the problem here. Everybody knows. I mean, more people will know this than this. Anyways, let's see what happens. You have a rhombus. Where is my rhombus tool? Here we go. You have a rhombus. You have a diagonal 12 and you have a diagonal 16. They are perpendicular and they bisect each other, so you have 6, 6, 8, 8, 90. Now 6 and 8 in a right angle triangle means the hypotenuse will be 10. We know that 6, 8, 10 is a Pythagorean triple. Yeah, you can add that to the list. Pythagorean triple, it doesn't matter. Pythagoras theorem. Not really a concern. Anyway, you have a circle inside, inscribed in this rhombus, which looks something like this. Let me see if I can get it. It looks something like this. Now what do we want? Let's work backwards. The ratio of the area of the circle, pi r square by half d1 d2 is what we want. We already have d1 and d2. Pi is a constant. All we need is r. We need to find r, and then we can solve this question. So that r is gonna look like this. Radius is perpendicular to the tangent. So remember this point right here. Both smaller triangles are gonna be similar to the bigger triangle. Now what that means is the two smaller triangles will also be 3, 4, 5 triangles with 3 and 4 on either side of the 90 and 5 as the hypotenuse. That's the ratio. So you have a 3x is to 4x here, which is also going to be 3y is to 4y here. 3 is to 4 and then again a 3 is to 4. You can actually combine these two. 3 is to 4, 3 is to 4. If you want to combine it, it will become 9 is to 12 is to 16. That's what I'm going to do next. 9 is to 12 is to 16. Now that means the radius to the side, radius of the circle to the side of the rhombus ratio is 12 by 9 plus 16. 12 by 25. This means that the radius is 12 by 25 times the side, which we already know to be 10. Cut a 5, 2 and 5, 24 by 5, 4.8. Now we are just one step away from the answer. We just have to evaluate this. Answer is equal to pi 4.8 square, which I'll choose to write as 4.8 into 4.8, because you will see that half d1 d2 is 6 into 16, 96. 48 by 96 is 1 by 2. So 4.8 by 96 is 1 by 20. This will give you 4.8 pi by 20. You multiply the numerator and the denominator by 5 by 4, I think. 5 by 4 will make it 6 pi by 25, which is now in the form of one of the options. Option B is your answer. Leaving home at the same time, Amal reaches office at 10:15 a.m. if he travels at 8 and at 9:40 a.m. if he travels at 15. Notice that we have two cases with the same distance, so inverse proportionality. Leaving home at 9:10, at what speed must he travel so as to reach the office at exactly 10 a.m.? Again the same distance. So this question, all it requires is inverse proportionality. We have speeds and times. Speed is 8, the time is, okay, we'll come back to that. Speed is 8 in case 1, speed is 15 in case 2. Comparing these, the time should be in the ratio 15t, 15 is to 8, so I'm going to take them as 15t and 8t. And what is the difference between these two times? 15t minus 8t is the difference between 9:40 and 10:15, which is 35 minutes. Which gives you 7t is equal to 35, t is equal to 5, which means this is 75 minutes and this is 40 minutes. Now you have a case 3 where you have to leave at 9:10 and reach at 10, which is 50 minutes. Now all you gotta do is, this 50 is 2 by 3 of 75, so the required speed should be 3 by 2 of 8. The final answer is 12. If A, B, C are positive integers such that AB is 432, BC is 96 and C less than 9, then the smallest possible value of A plus B plus C is which of the following? This is a very interesting question. It is ties to AMGM inequality from the inequalities chapter. In fact, in the absence of the integer constraint, I would tag it as AMGM inequality. It can still be done using that approach, but it's a bit tedious. You can just use a very logical approach instead. I'll mention both of them anyways. So the logical approach is very simple. You have A, B and C. These two have a product of 432, these two have a product of 96. Let me just move this down a bit. 432, 96, and we know that C is less than 9. So because of the integer constraint, we can exhaustively list all the cases and solve this that way. So let's list all factors of 96 which are less than 9. You have 8, 6, 4, 3, 2, 1. Now if C is 8, then B is going to be 12, and 432 by 12 is going to be 36. If C is 6, this is going to be 16, 4 by 16 is 25, 27. 4 into 24, 24 into 18 is 432, 3 into 32, you'll see that this case doesn't work. 432 by 32 is not an integer. 2 into 48, 48 into 9 is 432. 1 into 96 also doesn't work. Also the other thing that I'll point out is all values are under 60. So this case is already rejected because B plus C is already much bigger than 60. Anyways, also does not give an integer here, so you can check it. There are 4 valid cases here. You can calculate A plus B plus C for all of them. 48 plus 8, 56, present in the options. 43 plus 6, 49, also present. 42 plus 4, 46. 48 plus 11, 59. So basically all 4 valid cases give you numbers that are there in the options. You just want to take the smallest one, which would be 46. Now what we've used is basically prime factorization, which goes without saying in all questions where you have a product and integer factors. And what we use in logical reasoning, we made an exhaustive case definition and we worked through all the cases and we found the lowest one. So this is the logical solution to this without going into any rigorous algebra. Alternately, if you want to do that, you would say that B is 96 by C and then A is 432 by B, which is 432 by 96 by C. Now if you simplify this 432 by 96, you will get it as 9 by 2. 9 by 2 C. So then the A plus B plus C that we want, we can put it in terms of C. It is 9 by 2 C plus 96 by C plus C. which can then be written as 11 by 2c plus 96 by c. Notice that there are two terms whose product is a constant. There's a c in the numerator, there's a c in the denominator. The product is constant, so the geometric mean is constant. If you want to minimize the sum, you want to minimize the arithmetic mean. So AM GM inequality, and that would happen at the point where these two terms are equal. 11 by 2c is equal to 96 by c. But the only problem is the question also has an integer constraint, so you might not get the exact point. We'll have to take the closest integer to that. You also have to remember that all the terms a and b and c should be integers, so c has to be an even number and c has to be a factor of 96. You have to find a c value that makes this almost true, closest to being equal, or rather the even integer which is a factor of 96 which is less than 9, which comes closest to this value. That is what we're looking for. So then we have c square is equal to 192 by 11. 187 by 11 is 17, so 17 point something, 511 45 I think. Anyway, c square is 17.45. c is root of 17ish, is the ideal value if we did not have a positive integer constraint. With that constraint and with the even integer constraint, you will see that the best case scenario is c is equal to 4, which is the same thing that we got here. Now after you find c is equal to 4, you can just substitute it here and you'll get 11 by 2 into 4 plus 96 by 4 is equal to 46. Now that would be the rigorous algebraic approach. You can see that this is unnecessary because of the integer constraint. It's easier to just do a few cases. If y is a negative number such that 2 raised to y square log 5 to the base 3 is equal to 5 raised to log 3 to the base 2, then y is which of these options? Now all we need are logarithmic identities and to take log on both sides of this given equation. 2 raised to y square log 5 to the base 3 is equal to 5 raised to log 3 to the base 2. Take log on both sides. Then it becomes y square log 5 to the base 3, which I'm gonna write as log 5 by log 3, and then log 2. The RHS is log 3 to the base 2 goes outside as the coefficient. Log 3 to the base 2, I'm gonna write it as log 3 by log 2, and then you have your log 5. What I can cut is log 5 and log 5. Then what you need to do is you cross multiply log 3 and the log 2. So y square is log 3 into log 3 by log 2 into log 2. Now you know that log 3 by log 2 is a positive value, but we want y to be negative. It's given y is a negative number. Y is minus log 3 by log 2. Removing the, taking square root on both sides and taking the negative value of y is equal to minus log 3 by log 2, which is minus of log 3 to the base 2, which should become log 3 raised to minus 1 to the base 2, which is log 1 by 3 to the base 2. Option A. On a rectangular metal sheet of area 135 square inch, a circle is painted such that the circle touches opposite two sides. If the area of the sheet left unpainted is 2/3 of the painted area, then the perimeter of the rectangle in inches is how much? Some expressions are given. This is painted, this is unpainted. Now what you need to understand, first of all, this is one of the tougher and more time consuming questions in this quant section. Anyways, what you need to understand here is that this ratio determines shape. So ratio of areas, ratios of lengths usually in geometry will determine shape and not size. So the shape of the rectangle. What is the ratio of the length and the breadth can be found using just this 2/3 without using the 135. And then you can bring in the 135 to determine the size. You need to keep that in mind. Don't use 135 in the initial step, at least the way that I'm doing it. I'm just going to find the ratio of length and breadth first, at which point I'm not using the 135. So what we have here is unpainted by painted is 2:3, which means unpainted is 2/3. Painted by total is gonna be 3/5. 3/3 plus 2, 3/5. That's a good starting point to frame an equation, and I'm going to take the radius as r. So basically the breadth is 2r and the length is greater than 2r, because only touching two opposite sides, not touching the other two sides. So that dimension is longer than the diameter of 2r. I'm going to take it as xr and find x, at which point I will have the ratio of length and breadth. That's the first step. So painted area is pi r square and the total is length into breadth, xr into 2r. That's equal to 3/5. The r's will cancel. And you make x the subject. X is equal to 5 pi by 6. Slightly less than pi. So 2.5, slightly more than 2.5. That makes sense. Now x is 5 pi by 6. So my length is to breadth ratio is 5 pi by 6 is to 2, which can be rewritten as multiply by 6, 5 pi is to 12. Notice that this is 5, this is 5 and 12 by pi, which is in the same ratio. This is 5 by 2 and 6 by pi, which is also in the same ratio. At this point, I would say that these are my top two contenders for the correct answer. 3 and 12 pi by 3 and 12 by pi are different ratios. Probably not the right answer. If you're pressed for time, you can choose one of the two and just move on, or mark for review and move on. Anyways, 5 pi is to 12 is the ratio of the length and the breadth. Let the actual lengths and breadths be 5k and 5 pi k and 12k. Now we're going to bring in the area of 135. This is where we have dealt with the shape. Shape is known to us. Now we're going to incorporate the size and then use that to find the perimeter. So we have L into B is 135. 60 pi k square is 135. K square is 135 by 60 pi. You will see that this is, you can take out 15, it becomes 9 by 4 pi, which basically means k is 3 by 2 root pi. So that's where we get the root. Now the answer is the perimeter. It is 2 times L plus B, which will become 2k times 5 pi plus 12, which is 2 into 3 by 2 root pi 5 pi plus 12. The 2's will cancel. We have a 3 by root pi into 5 pi plus 12. I am going to multiply and divide by pi to make it 3 root pi into 5 plus 12 by pi. 3 root pi into 5 plus 12 by pi. First option. In a group of people, 28% of the members are young while the rest are old. If 65% of the members are literates and 25% of the literates are young, then the percentage of old people among the literates is nearest to which of these 4 integers? Now there are many ways of doing this. You could go for a 2-set Venn diagram, you could go for a 2D matrix, practically the same the situation. You could chuck any visual representation entirely and use just a bunch of equations. But I feel the most efficient way of doing this would be to use weighted average. Use a number line and use that to find 1 or 3 missing points on that number line. How do you do that? The idea being you have a mixture of literates and illiterates. Think of it that way. And then what we have is among the literates 25% are young, which means old people in literate is 75%. So you have 2 components that are being mixed, 2 groups being mixed, the literate people and the illiterate people for the total group. Among the literates 75% are old. Among the group 72% are old because 28% are young. Among the illiterates, what percentage are old is the question. So you can just put a number line. 75% of literates are old, 72% of the mixture is old. What percent of the illiterates are old? What else is given to us? 65% of the members are literates. So you have a 65:35 split, approximately 1:2. Invert that ratio, 2:1. You have a distance of 3% percentage points here, so you should have 6 here, giving you approximately 66. An alloy is prepared by mixing metals ABC in the proportion 3:4:7 by volume. Weights of the same volume of metals ABC are in the ratio 5:2:6. In 130 kg of the alloy, the weight in kg of the metal C is which of these numbers? Now, in spite of the fact that alloy is mentioned, this is nothing to do with mixtures. What we're using in this question is joint variation and direct proportion. So we are given that weights of the same volume are in the ratio 5:6. So weight per volume for A and B and C are in the ratio 5:2:6. If you multiply weight per volume with volume, you will get weight. Volumes in this particular alloy should be in the ratio 3:4:7. So you take the 3:4:7, and if you multiply it, the actual weights of the metals in this alloy should be in the ratio 5:3, 15 is to 2:4, 8 is to 6:7, 42. The weights in this alloy should be in the ratio 15:8:42. Add it up, you will see that this is actually 65 parts. Notice how they've given you a very convenient multiple of 65 here. 65 parts is 130 kg. If that is the case, then what is the weight of metal C? C is 42 parts. that should be 84 kg. A gentleman decided to treat a few children in the following manner. He gives half of his total stock of toffees and one extra to the first child, and then half of the remaining stock along with one extra to the second, and continues giving away in this fashion. His total stock exhausts after he takes care of 5 children. How many toffees are there in his stock initially? Now, this is the kind of common sense question that you can count on cat to throw you. Now, if you really want to tag this to a topic in quant, one way you can do this is to simply say that this is a linear equation in one variable. There are a couple of quite a few operations there, but you can do a combination of transposition and cross multiplication and you can get your answer. It's a linear equation. Or I could say that this you could relate this to functions and inverse functions in particular. So basically the number of toffees I have after I interact with one child is a function of the number of toffees I have before I interact with him, and this function is linear and invertible, and you can use the inverse function to explain a solution. But the general principle, without going into this sort of an abstraction, is very simple. Work backwards from the known to the unknown. The unknown is the number of toffees I had before I interacted with the 5 children. The known is what I had after interacting with them, which is 0 toffees. Work backwards. And usually when you have this, we deal with a process where we do the inverse operations in the reverse order. This is basically it. This is all you need to do. You don't need to know what an inverse function is to actually solve it. Now let's understand what happens in a step. If you have n toffees with you, what are you gonna give to one kid? You're gonna give him n by 2 and an extra. So if you give that, what do you have left with you? This is gonna be n by 2 minus 1. What's left with you is 1 less than half of what used to be with you before their interaction. So it's basically divide by 2 minus 1. So I have a number. Let me just write that somewhere else. I have a number with in an interaction becomes divide by 2 minus 1. There's a second interaction, a third, a fourth, and a fifth, and then your final output is 0. Now you can actually do this in the reverse direction and find n. So you have to do the inverse operations in the reverse order. You start with 0, you have to do plus 1 into 2, plus 1 into 2, plus 1 into 2, plus 1 into 2, plus 1 into 2. So that's gonna be 1, 2, 3, 6, 7, 14, 15, 30, 31, 62. If you want, you can verify this. You start with 62. You are giving him half, which is 31, plus another 1. So you're going to give him 32 and you will have 30 left. If you have 30 left, you give half plus 1 is 15 plus 1 14. Sorry, 15 plus 1 16. You'll have 14 left. Notice that these are the same numbers you have here. If you have 14 with you, you give that third person half of that, 7 plus a 1, 8. You give 8 out of the 14, you'll have 6 left. Then you'll give 3 plus 1, 4, and you'll have 2 left, and then you'll give 1 plus 1, 2, and you'll have 0 left. Notice these are the same numbers. that you have here. What have you done? You've done the inverse operations in the reverse order. Final answer is 62. Now, what was I referring to when I was talking about inverse functions? Again, if you had n and you give n by 2 plus 1, you will have n by 2 minus 1 left. So this is a function. What I have after interaction is a function of what I had before the interaction. So f of n is equal to n by 2 minus 1. And the question is basically saying after 5 interactions, I have exhausted my stock. So it's basically f of 5, f raised to 5n, f of n is 0. Now what you need to do is basically the inverse function. Inverse function is, if you calculate it, you will see that it is twice n plus 1. What this means is the number of toffees I have before an interaction is twice of one more than what I had after the interaction. You can find this inverse function. It's pretty easy because it's a linear function. Now if you call it g of n, just for the sake of giving it a new name, essentially your answer is g of 0. If you evaluate it, you will get it as 62. You don't need to do any of this, just saying that this is one way of looking at this problem. Inverse functions. A solution of volume 40 liters is dye and water in the ratio 2:3. Total 40, 2:3. That's going to be 16 and 24. Water is added to the solution to change this proportion to 2:5. So the quantity of dye remains 16. 16 is 2 parts, so 1 part is 8. So then that means 5 part is 40. And the total is 56, but we don't actually need that. Next step. 1/4 of this diluted solution is taken out. So -4 minus 10. What's left is 1230 for a total of 42. Again, we don't need that. After this taken out, how many liters of dye must be added to the remaining solution to bring the proportion back to 2:3? Dye is being added, water is remaining the same, so it's 30 and something, but that's in the ratio 2:3, so that something has to be 20, which means 8 liters has to be added. The final answer is 8. What concepts are we using? All we need is direct proportion, nothing else.